Good everyone, my name is Graphics. In this video, we are to solve the reaction that is involved in this system. Now, if you look at this system, it is a overhanging beam, right? That has two supports. One of the support at A is called the pin support or the hinge support. Another one at point B is called the roller support. And this overhanging beam has three different kind of loading. The first load is a point load of 5 kilonewton. The other load is called the UDL, that is uniformly distributed load, that is spread across a length of what, 2 meter. And the other load is a UVL, uniformly varying load, that is across a length of what, 1.5 meter. Now we have A, B. Let's say this point here is point C, and this point here is point D. Then here will be what? Point E. Now the reason why we are calling this an overhanging beam, because of what? The beam is extended from what? From the support. So the first thing you have to do is to draw your free body diagram, right? So let's see. At the point A here, since it's a pin support, we have two reactions. We'll call the vertical reaction to be, we'll call it to be RAY. That is the reaction at point A along y-axis. In free body diagram, we'll call support, it has what is called the reaction. And this is called the RAX. That is the reaction along what? Along x-axis, at point A along x-axis, right? I will know this is our point A here. Now the other one, we have what is called the 5 kilonewton at a distance of what? 1 meter. So I'll put the 5 kilonewton here. So this is our 5 kilonewton. 5 kilonewton, right? And we have a moment at point D here. We have this going this way, and that will give us as 20 kilonewton. 20 kilonewton meter, just like in the question, 20 kilonewton meter, right? Now you see this is a UDL across a length of what? 2 meter. So the way you convert this to a point load is that you multiply, we have what is called 4 kilonewton per what? Per meter. You multiply with the length at which it is covering, which is what? 2 meter. So 2 equal to, so 2 times 4 is 8. So the 8 will be acting at the center of what? Of this, of 2 here. So I'm going to put this way. And from this point to this point will be my 8 kilonewton at a distance of, since from here to here is 2, that means the distance from this point here to this point here and back to this point here will be 1 meter. Let me just do that so we'll see. So from here, we're having this to be, so this is 1 meter, this is 1 meter, and the entire length from here to here is given as what? As 2 meter, just like it is shown in the diagram above. So from here to here is 2, but because we have converting it to point load, the point load is 8 kilonewton. What we did here, that we're having what? 8 kilonewton to be acting at the center of the 2, right? Now we know this is our point D, and this is our point B, right? This is our point C, and this is what we have, we'll call it point A. Now the next thing we're going to do here is this. This is a UVL, uniformly varying load. So we need to convert it also to a point load. We know that it is acting across a length of what? 1.5 meter from here. Across a length of what? 1.5 meter. So this is, from here to here is 1.5 meter. This way, we have 1.5 meter, right? Now we know from here to here, this is 1 meter, and here also is another 1 meter. So we say that we'll convert this to a point load. So this is the head and this is what? The apex. So if I'm coming from the head, the formula I'm going to use will be, first of all, let me calculate the total area of this shape. Is a triangle, right? Is a triangle, right? So I'll be having half base times height. So the area here will be equal to what? Half base times what? Times height. Now what is the base here? The base here is giving us what? As the distance, the total distance, which is what? 1.5. Right? Multiplied by the height is giving us the 10 kilonewton per meter. So we have 1.5 meter, 1.5 meter here, multiplied by what? The 10 kilonewton. Right? So that is height base times height. So from here to here, I'm going to be having this to be equals to, if you move this, we're having half base times height. So 1.5 times 10 is what? 1.5 times 10 will give us 15. And 15 divided by 2 will give us what? 7.5. Right? So we're going to be having what? 7.5. So we're having 7.5. 7.5 kilonewton. Right? So the force of this acting here is what? 7.5 kilonewton. So that if you multiply the entire distance from here to here is 1.5, multiplied by the 10, and that is what? 15. Then 15 divided by 2 is what? 7.5, right? So that 7.5, where will it be located along this distance of what? BE. We will use 2 over 3 multiplied by what? The length. What is the length? The length is what? 1.5. Right? So when we do that, 2 over 3 means that what? 3 all over what? 3, and that will give us what? 1 meter. So the distance at which this 7.5 kilonewton will be located from the head here is what? Is 1 meter. So I'm going to measure 1 meter. Let's say from here to here is the 1 meter here. So this is where I am going to actually place my what? 7.5. So this is the what? The 7.5 kilonewton. 7.5 what? Kilonewton acting at that point, right? So if you look at it, that we have 10 kilonewton per meter, right? So this meter will equate this. So 15 times 10 is what? That will have 7.5 kilonewton. Now the next thing we'll be doing here is at this point E, there's something we'll call the load here at 25 kilonewtons is inclined at an angle of 30 degrees. I'm going to resolve. So resolving it, I'm going to have, if you don't know how to resolve, we'll call it resolution of what? Of forces. You can just click this link and to show you on how you can resolve forces that can incline at an angle, right? So from here, I am going to draw a vertical line here, this way. And I'm going to draw an horizontal line here, this way. Since the force is going in, this will be coming in this way, and this will be coming here this way. So here the vertical line will be 25 sine 30. Here will be what? 25 cos 30, right? So what we just did now, we'll call it resolution of what? Of forces. Is that okay? So from here, we'll start. We've successfully converted all this into point load to make our work more easier. Now what we'll do, the first condition for equilibrium is we want to look for the reaction ROAX, ROAY, and the last but not the least, at point B, we have what is called the roller support. So that will give me just one reaction. So I'll put it this way. That will be just one reaction here. At point B, I'll call it my ROBY. Since the roller support have just one reaction. We'll call it what? ROBY. Is that okay now? So let's move forward. Now the first condition for equilibrium is the summation of f of x, right, equals to what? 0. Now it means all horizontal components must be equated to what? To 0. Now we are going to consider the upward forward force to be positive and the backward force to be what? Negative, right? So we have ROX is an horizontal component we'll write it is facing forward, so that will be what? Positive. And we have 25 cos 30 facing backward, that will be minus 25 cos 30, right? And this will give me equals to what? 0. So we'll now say that the arrow AX will now be equals to 25 cos 30, right? It's coming here, it becomes positive. So we'll now say that arrow AX will now be, when you press 25 cos 30, we'll be having 21.651 kilonewton. So that is the arrow X. Now we'll move forward. Now from here, we will now look for what? The summation of what? Vertical component. Summation of F of Y will be equals to what? 0. Now we are going to consider any force acting upward to be what? Positive, and any force acting downward to be what? Negative, right? So let's see. My arrow AY and arrow BY are acting upward, so I'll say the arrow AY plus what? The arrow BY, right? Then we have 5, 20, we have 5, 8, they're acting downward, so we have minus, because they're acting downward, minus 8, minus 5, minus 7.5, right? Then 25 sine 30 is giving us, let us put it, minus what? 25 sine 30. Now, I'm not including this because this is a moment. It is not a force acting downward. It's a turning force, right? Now, this is all we have. 5, 8, 7.5, and 25 sine 30. And why they are negative? Because of what? They are facing downward. My condition says any force facing downward should be what? Should be negative. Now, equals to what? 0. Now, when I say that, my arrow AY plus arrow BY, now, minus 5 minus 8, right? We have minus 5, minus 8, minus 7.5, minus what? 12.5 equals to 0, because 25 sine 30 will give you 12.5. Now when you do that, minus 5 minus 12.5, minus 5 plus, minus 5 minus 8, minus 7.5, minus 7.5 will give us, so when you add everything here, you now be having arrow AY plus arrow BY minus, we'll be having just 33. We're having 33 here equals to what? 0, because minus 5, 7 minus 7.5 minus 12.5 will give us what? 20, right? Then 20 plus 8 will give us what? 28. 28 plus 5 will give us what? 33. So because they are all negative, I'm putting negative 33 here. So we'll now say that the arrow AY plus arrow BY will now be equals to what? 33 kilonewton. I will term that my equation what? Equation 1. You can see that? Now we'll move forward. The next thing will now be what? We will now take moments. Now if I take moment, the third one, if I not take moment from this point here, let's do this. If I take moment about any point of my choice, let's say moment about point A, right? Moment about point A equals to what? 0. Then I'm going to consider, I'll consider the clockwise moment to be positive and the anti-clockwise moment to be what? Negative. So when I do that, we will now start. What is moment? We know moment is what? Force times distance, right? So since I take moment about, if you don't know about how to calculate for moment, you can just click on this link at the top right corner of the screen, and it will take you to a place where you can learn how to find the moment of force about the point. So the moment of force, about these forces, why we are using summation of moment, because we have more than one force. So it will be 5. Look at this here. We have 5 kilonewton, right? Since I'm talking moment about A, 5 will be coming towards A. Now what do you notice is going in this direction. And when you have your clock this way, let me show you. I have my clock this way. This is 12, this is 6, this is 3, and this is what? 9. If you go in this direction, that is direction of the clock, so we'll call it clockwise. And we say the clockwise moment, this one you see here, is what? Is positive. So it will be 5 times 1. So I'm going to move from there. I'm going to put 5 multiplied by 1 plus, I'll go to the next one again. From here, this is a moment, but it's going in this direction. You can see, and that's anti-clockwise, so minus 20. So I'll move there. That will give us into bracket minus 20 plus the next one again we have is this, and that is 8. 8 is coming this direction towards point A. From 8 to A is giving us, this is 1, 2, 3. That will be 8 times 3. So I'll move from there. 8 times what? 3 is still clockwise, because look at the direction of the 8. It's still moving in this direction of the clock. Now the next one we are going to do is the 7.5 from here, right? So it will be the 7.5. This is 1, right? 2, 3, 4, 5. So 7.5 times 5, and that is what? Still clockwise. But before then, before the 7.5, we have what is called the ROBY, which is going in this direction, and that is anti-clockwise towards point A. So ROBY times, this is 1, 2, 3, 4. So that will be minus ROBY times 4. So we have minus, that will be plus bracket, minus ROBY times 4. Then plus the next one, which is 7.5, is going in this direction too. Everything you are doing will be going towards A. And that will be 7.5, this is clockwise, times 1, 2, 3, 4, 5. The distance from that point to the point A, and that is 5. So 7.5 times 5. So we have 7.5 times 5, right? Then the next one will be plus into brackets. Let's see the next one here. We have this coming in this direction also. That is 25 sine 30, which is positive. It's going clockwise. So 25 sine 30 is 12.5, right? So from here it will now be 1.5. This is from here to here is 1.5 plus 2, 2.5, 3.5. That will have 5.5. The total distance there is what? 5.5. From here to here is given as what? 5.5. So I'll multiply the 12.5 times 5.5. So we have 12.5, right? Times what? Times 5.5. Everything equals to what? 0. I can't use this because this is not perpendicular to this distance here. It is horizontal, so I'm only using the perpendicular distances. And from here we'll now start. We know that 5 times 1 is 5, minus times plus is minus, so we have 20 plus 24 minus 4 ROBY, right? Then we have 7.5 times 5 will give us, so that will give us 37.5 when you multiply it together. So we have plus 37.5, then plus 12.5 times 5.5, that will give us 68.75 equals to what? 0. Now when you add, we're going to add, we have 5 minus 20, that is what? 15. That is minus 15. So minus 15 plus 24, that will give us, so So when you add it with 37.5 and 68.75, everything you'll be having will be 105.25, right? Minus 4 RBY will now be equals to what? 0. So 105.25 is equals to what? 4 RBY, right? Now RBY will now be equals to what? 105.25 divided by what? 4. And we are going to be having this. So we're having this coming. Sorry, we'll be having 115.25. So this is 115. This is another 115. This is 115. Is that okay? So from here, if we divide that by 4, we'll be dividing this by 4. And that will give us 28.813. So my RBY will now give us what? 28.813 kilonewton. That is the reaction at BY. So we will now substitute this RBY into equation 1 above. Now this is the equation 1 here. So substituting it, when I say that substitute RBY into equation what? 1 above. So equation 1 above is telling me that RAY plus RBY will now be equal to what? 33. So my RAY plus 28.813 will be equal to what? 33. So from here we'll now say that RAY will now be equal to 33 minus what? 28.813. And that will give me, if you subtract 33 minus 28.813, and that will give me 4.187 kilonewton, right? So this is the reaction at what? At RAY. So we'll now say that therefore my RAX will calculate to give us what? 21.651. RAY calculate to give me as 4.187 kilonewton. Then my RBY will give us as what? 28.813 kilonewton. Now this is all what we have here. If you have found this video helpful, please don't forget to click on the subscribe button, like, share, and also comment.